Thank you, John. So Emily Carney is a spaceflight enthusiast and author from St. Petersburg, Florida, and she's going to tell you a little bit about how convenient that was at just before 6 o'clock in the morning in a few minutes. But she is an expert in many things space. She's worked as a freelance writer. She's got a blog. She hosts webcasts. And a major claim to fame is 10 years ago, she started a Facebook group called Space Hipsters.
Well, you can watch TV. I can go in the other my bedroom
and so she has quite an amazing following and a lot of fantastic information on her Facebook group, and a lot of people who've connected over the years and meet at the annual Space Fest convention in Tucson. I met her down there, and Chris Gaynor also knows her quite well. So it just seemed to me a great opportunity to invite her to join us and talk about something that was near and dear to her heart, and that is the Skylab program. So before I ask her to share her screen and show us her presentation, I wanted her to spend a few minutes telling about the launch that she saw this morning. Many of you, if you've been on social media, saw that there was a SpaceX Dragon launch to the space station this morning, but because of the time being pre-dawn, it was a spectacular view for thousands of people in Florida and up along the East Coast. And Emily got her up early and saw it, and took some pictures and has posted some video. And so I was going to ask her for a first-hand account.
Yes. Good evening. I'm Emily Carney, and I will tell you about this morning's Crew 2 launch. I woke up around 5:30, and I was like, why did I set my alarm to get up this early? And then I remembered, there's a launch this morning. So I got up and drove to the end of my neighborhood, which faces towards the east, towards Cape Canaveral and Kennedy Space Center and all that, and went up out there and watched the launch, and it was incredible. It went off on time, which is amazing. And unfortunately, not to diss SpaceX or anything like that, but not all launches go off on time, and they have an instantaneous launch window for the Falcon 9 going to the ISS. So they had to get it off perfectly at 5:49 a.m. So it went off on time, and within about a minute, I saw the orange plume going over the horizon. It looked like an orange comet. It was incredible, and I was like, "Yeah, that's the Falcon 9. All right, they're getting on their way." Then, within a few minutes, when the first stage separated from the Crew Dragon and all that, it was the most incredible sight. One of the most incredible sights I've ever seen. I saw the Crew Dragon was like on the left, and it was obviously hauling its butt towards the ISS to space. And then you could see the first stage doing its boost back, and you could see like the plumes coming off of it. And I mean, it was just mind blowing. And with the sunlight, the sun was starting to rise. So there was sort of this, diffusion, in the atmosphere, and it lit everything up. And I mean, it just looked absolutely incredible. It was probably the most beautiful launch I've ever seen in my life. And I've seen probably hundreds of launches. So yeah, so that was probably the most.
So if you want to, if there's anything that you need, I'm going to be going out.
Sorry, that was probably the most beautiful thing I've ever seen. As far as a launch is concerned, I've seen probably hundreds of launches in my life, including shuttle and stuff like that. It was just absolutely gorgeous. So I'm extremely glad that I woke up this morning and didn't hit the snooze alarm. So yeah. So I guess
it was really the timing that made it, because I've seen some Soviet launches at and around like an hour and a half before dawn. and it's nighttime where they launch, but once it gets up to altitude and you get into the sunlight, and then all of this stuff spewing out of the engine just lights up like, I don't know, ice and just amazing stuff. It's just unreal how much it spews out, and it's such a wide angle from the engine.
Absolutely, yeah. And even though I'm about 130 miles away from Kennedy Space Center, it's not that far away, but it's about a 2-hour drive roughly, give or take, if you're speeding. And it was just absolutely mind-blowing just to see that, first thing in the morning. So it was gorgeous. And early morning launches tend to be really beautiful. If it's clear out, tend to be really beautiful anyway. So just because, the sunrise color sort of juxtaposed with, just this flaming rocket going up. So it was just gorgeous. So I'm very blessed to live in Florida, where we have a lot of those. But this morning was very unique. I have never seen anything like that. I hope to see something like that again. So, all right.
I bet. All right. Why don't we move on to our main topic tonight? And if Emily, if you want to share your screen and get your presentation up, I will hand it over to you, and you can tell us all the cool stuff about the Skylab program.
Absolutely. Let me share my screen. All right. Okay, we're going to start the show. I did talk a little bit about the SpaceX launch this morning, and the SpaceX launch did send 4 people to the ISS. We have 2 American astronauts, 1 French astronaut from the ESA, and we had a Japanese astronaut as well. And the reason why I'm talking about this is because the ISS, which they're going to, is really the direct descendant of what I'm about to talk about, which is Skylab, America's first space station. So we're going to talk about that tonight. But first, we're going to start at the end of Skylab. That's right. According to the NASA history book, Living and Working in Space, the NASA history of Skylab, Skylab 4's commander, Jerry Carr, boosted the space station's orbit by firing the Apollo spacecraft's attitude control thrusters for 3 minutes at the end of his crew's 1973 to 74 mission. Now, it was then expected that Skylab might remain in orbit for another 9 years. So they were thinking at NASA, they were like, well, it'll be up until about 1983, right? So by 1977, that expectancy shifted to 1980, which was the solar maximum year. But in 1978, it was clear that Skylab might come down even sooner than expected. Now, ground controllers worked hard to regain control of its onboard systems and its computers, which actually was pretty easy, and I might talk about that a little later in the talk. They wanted to prevent the large cluster from really coming down upon inhabited areas. But by 1979, even the American comedian, some of you might remember him, John Belushi, was making fun of Skylab on late night television, assuming that somehow Skylab would come down over his apartment. If you look at the picture of him at the right, he's holding a really inaccurate Skylab model, so it's pretty funny. I don't know if the clip is available on YouTube, but it's still pretty funny. So, all right. So, okay, the space station's life, and here we see the Skylab shields here. Skylab's reentry was kind of a boon for the novelty industry. They started selling T-shirts, and here's the Skylab protective helmet here. I've seen a few of those on eBay. People started selling prank gifts about, Skylab coming down. So the space station's life came to a close southeast of Perth, Australia on July 11th, 1979. Now, the NASA history book that I mentioned before stated, spectacular visual effects were reported, and many residents heard sonic booms and whirring noises as the chunks passed overhead in the early morning darkness. Now, thankfully, while some debris did come down, and there's probably more debris that hasn't been uncovered yet, nothing harmed any people or any property. But obviously the anticipation of reentry had, made retailers sell stuff like what we're seeing here. So America's first space station was really reduced to a kind of a crude joke by this point. Okay, so before late night television jokes and before the reentry, what was Skylab? It was and continues to be more than a punchline. In its prime from 1973 to 1974, it was the United States and really arguably the world's first true scientific platform in space, and it led research in the areas of space medicine, Earth observations, and solar physics, among other things. In addition, the astronauts really became the first teachers in space. They conducted science lessons and student-driven experiments. And it also gave us space fans probably one of the best space rescue stories of all time. Okay, here is George Mueller's August 19th, 1966 drawing of the space station concept that would eventually evolve into Skylab. Now let's talk about a little bit about the Apollo Applications Program, which focused on the idea of creating infrastructure and missions based on existing Apollo and Saturn hardware. Now, during this time, the NASA budget, this was in the mid-1960s, it really seemed, but it wasn't, limitless. And many ideas utilizing Apollo hardware were being discussed at the time. One of the really cool ideas even involved sending humans on a Venus flyby mission. If that had gotten past the drawing board, that would have flown into deep space around the early 1970s. But I digress. Okay, back to the S4B based space station. Here's one of the many concepts floated around for such a space station. If you look at this concept here, note that there are three, let me get my pointer here. There are three Apollo spacecraft docked to the space station. I'm honestly not sure myself if these were meant to ferry crews back and forth to the space station, or if maybe one or two of them function as logistic spacecraft, like cargo spacecraft. The first logistic spacecraft, which was Progress 1, would not be launched until 1978, and that was to replenish the Soviet space station Salyut 6. So here's an early concept, and this is from around 1967. Okay, here's another S4B rocket stage space station concept. If you look here, let me take my pointer if you guys can see it. You note that there is an engine bell on the space station here. Now, this was a proposed design for a wet workshop space station. Let me try to explain a little bit what a wet workshop meant. That meant the crew, this would go up as a rocket. It would be fully fueled. The crew would then drain any remaining propellant from the spent rocket stage during an extracurricular activity. Now, if you also look, let me get my pointer here. If you look at the Apollo telescope mount, the windmill-shaped thing up here, if you look at this piece here, it resembles a lunar module. There's a reason for that. The Apollo telescope mount design was originally based on the lunar module and would have been flying free to dock initially with the space station. So this concept was actually really futuristic. It would have been modular, and it would have just been put up in several different pieces. Now, did you know that Skylab could have had a robotic arm? This is a fact. It could have had a robotic arm. At one point, it was proposed that the S4B-based space station have an arm to transport an astronaut and 7 film magazines to the ATM during service EVAs. Now, this is not a great scan. This is from some paperwork I found. So it's not really a beautiful scan, and it's probably from 1967 or 68. But as you can see, there's a little model here. It's a little space. Hey, it's a little Ed Gibson here. Okay, you see him. He's perched on the end of what looks like a highly jointed arm. So there we go. So Hans Venture of Huntsville, Alabama's Marshall Space Flight Manufacturing Engineering Laboratory conceived a manipulating device to aid in assembling and servicing structures in space. This 40-foot long arm would have had more dexterity than the Canada arm, which we all know from the space shuttle years. And no offense to Canada, but we almost had it first. And a small version of this arm was even constructed for the neutral buoyancy simulator at Marshall for testing in 1967. And it was called the serpentine actuator, or the serpentuator, because it looked kind of like a snake. Now, here's a view of the development model of the serpentuator at Marshall. And you can notice there are many joints to it, and there's a chair on the end. Kind of looks scary, like a bit of a torture device. So there, like I said, this was a pneumatic version of the serpentuator, and it was operated using air bearings, which are the jellyfish-like things on the bottom there. So that was a version of what that may have looked like. Okay, now by May 1967, according to the website Encyclopedia Astronautica, as many as 2 wet workshops, 2 dry workshops, 3 Apollo telescope mounts, 2 Saturn V's, and 25 Saturn 1B's, which were the smaller rockets. If you watch For All Mankind, the TV show, you may have seen Apollo-Soyuz launched from the milk stool. Those were those rockets. Those were to be allocated to the AAP program for what would become Skylab. Now, by the late 1960s, as we all know, budget cuts really created a ton of missed opportunities. So a research and development EVA performed by George Mueller and Werner von Braun showed the 2 men that the wet workshop idea was really too cumbersome. If they couldn't do it in a spacesuit, then astronauts probably wouldn't be able to do it. So by I think May 1969, the wet workshop design, as well as the idea of having a serpentuator arm, was really deemed too complex, too unwieldy, and just too expensive. So it was decided to use a dry workshop. What that means is it would be launched with no propellant in it, and the space station would be launched in one piece as a cluster aboard the Saturn V. Now, if you see pictures of Skylab, and we'll see some more during this presentation, the space station still had hallmarks of its wet workshop days, most notably the floors that were gridded that had sort of the triangular pattern in it. So that was one sort of leftover from those days. Now, by February 1970, the space station gained a name, Skylab, which I think is a pretty beautiful name. So really only 2 AAP programs remained unscathed by the late 1960s budget cuts. That was Skylab, and as many of you know, the Apollo-Soyuz test project, which flew in 1975. And we also know that we just passed its 40th anniversary. The first robotic arm wouldn't be flown until 1981, and I don't think it was tested until late 1981, which was Canadarm. Okay, this is not related to Skylab, but I wanted to discuss it a little bit. This is another concept for a space station from the 1960s. So while NASA envisioned infrastructure in space, which was based on the Saturn S4B stage, the United States Air Force wanted to have its own space station for scientific purposes. When I say that, I mean reconnaissance, to spy on people. Two of its astronauts from that program, who were Bob Crippen and Bo Bobko, flew on SMEAT. We will find out what SMEAT is in an upcoming slide. This would have been based on the Titan II rocket, and this station would have performed reconnaissance operations in space utilizing the KH-10 optical system, basically a large telescope. Now, by 1969, MOL was largely superseded by robotic reconnaissance satellites. So it was really kind of redundant that they would have to launch something like that. So it was canceled. So there you go. But that's what it would have looked like. And it was, as you can see, some of you may have recognized, it's based on, here's the Titan II rocket shaped station. And here is a Gemini capsule. So you would have had two astronauts faring up there on a Gemini capsule, and they would have lived in that volume that had a quite amazing telescope in it. All right, I told you I would talk about SMEAT, so we're going to talk about SMEAT. Hold on. So this SMEAT stands for the Skylab Medical Experiment Altitude Test, and it's from 1972. Here's the little patch here of Snoopy being chained or being roped to the ground. There is a reason for that. This test took place from July 26th to September 19th, 1972 at NASA's Manned Space Flight Center. That's what it was called back then, in Houston. And the commander was Bob Crippen, the pilot was Bo Bobko, and the science pilot was Dr. Bill Thornton, who passed away recently. This was a 56-day simulation in sort of a pressure chamber of a Skylab mission, and it enabled the crewmen to collect medical experiment baseline data and evaluate equipment and operating procedures. If you're really interested in finding out more about this, Dr. Bill Thornton's papers are available via the Moody Medical Library. There's a lot of amazing stuff in that archive if you really want to go through it. But one notable thing from this test is I think Thornton set the bicycle ergometer on fire at one point, which is pretty funny. So, yeah. But it was 56 days. It was basically sort of like a Skylab Earth analog. And this really, seriously, this actually set this mission, even though obviously they didn't leave the Earth, it set the stage for other Earth analog missions. Like, for example, you have people who are simulate Mars missions on the ground now. So this was something that sort of set a precedent for things like that in the future. All right, so here was what Skylab was supposed to look like. The space station cluster consisted of the CSM, the command and service module, the multiple docking adapter, the S4B orbital workshop, the airlock module, and the Apollo telescope mount. It was, and to my knowledge, remains the single largest object launched into space. The Russian Mir space station and the current ISS obviously were large, but they were put together in pieces. They were modular, so they were launched up in sections, whereas Skylab was launched in just one shot, mostly one shot. We'll talk a little more about that. And it weighed, let's see, yeah, it had 354 cubic meters of work volume, which is a lot, and it weighed about 200,000 pounds, so very large. and here's what it was supposed to look like. There's a reason I'm saying that. It has 2 solar panels. They have a cutaway, so you can't see the micrometeoroid shield, but it looks very nice and shiny, right? Okay, here's a picture of a Tang ad on the left. Some of you might remember Tang. I don't know if they still sell that or not. It's the really sugary orange drink. But they had a Skylab ad there on the left, and that kind of shows how Skylab did have a presence in pop culture during that time. So, and on the right is a beautiful photo of Skylab's actual launch. Now, as you can see, it was kind of an overcast day, and this is going to, the reason why I'm telling you that is it's going to come into play in a couple minutes when we find out what happened during the launch. So there's a beautiful color photo of Skylab's launch. And here is a black and white photo of the launch, and this is shortly before it disappeared into the clouds. It disappeared into the clouds within about 60 seconds. The reason why I'm saying 60 seconds is something also to keep in the back of your mind. So, okay, now here is what greeted the first crew. Sure looks different from how it was supposed to look like. It does not look like the exquisite vision from the Tang ad. So how did this happen? As you can see here, one solar panel, see this bundle of wires here? It's completely gone. This solar panel here is accordion to the side of the space station, and the micrometeoroid shield is gone. And you can see some discoloration here as well. I'm not sure if the discoloration is from the heat of the sun or if it's just from the shield tearing off or not. But let's talk a little bit about how this happened. So it's kind of complex, but I'll try to sum it up. It's often reported that the micrometeoroid shield and the SAS-2 solar wing were lost at the same time during max Q, which is the period of maximum aerodynamic pressure. This was not the case. What actually happened was around 60 seconds into the launch, around the time it disappeared into the clouds, the micrometeoroid shield began to detach. This was at about 26,800 feet in altitude. When it detached, if it had actually been a clear day out, you probably would have been able to see it. But because it was overcast, nobody was able to see that happening. Now, also, when the micrometeoroid shield went away, it loosened up the solar panels. Approximately 10 minutes into the ascent, the S2 shutdown and separation sequence resulted in the complete loss of the SAS-2 solar panel. The other solar panel did stay attached only because it was held down by debris from the micrometeoroid shield. Something arguably worse, though, that many people don't know about, happened during Skylab's ascent. So when the micrometeoroid shield came off, it hit the Saturn V at least twice. The second blow to the rocket had nearly devastating consequences, as author Wes Olszewski reported that the micrometeoroid shield impact included the second plane separation point where the linear shaped charge was located that pyrotechnically blows the parts of the airframe apart so that the skirt ring can be dropped after first stage separation. Basically what this means in English for non-space nerds is that the S2 skirt separation did not happen. Some of you may have seen the famous Apollo 4 movie, and there's a screenshot of it at left. It's showing like a ring coming off the S2 stage. That's supposed to come off. In this case, it didn't because of what I just described. And if it hadn't happened during, let's say, a lunar mission with people inside, they would have had to abort. But in this case, it just kept on going, and the temperature inside the stage really started to spike unacceptably, which is why, had people been inside, they would have aborted and come back home. It would have been kind of a bad day. Or not a bad day, but kind of an annoying day. They wouldn't have been going to the moon that day. So it has been surmised that this stage was probably moments from failure when its outboard engine shut down. And Skylab almost could have been lost forever. So we're going to talk a little bit about the backup crew. Because of the loss of the shield, temperatures inside the space station just spiked to about 120 degrees, and that threatened materials inside the space station. There were really concerns that the overheating interiors might release toxic gas that could make the space station uninhabitable. There was also a power deficit that really threatened to curtail future missions. But don't despair, because enter this snazzy looking backup crew here. We got here on the left, this is Bruce Mccandless. Some of you might know who he is. He's the gentleman who flew the manned maneuvering unit in space and was in that famous photo in the middle. That's Commander Rusty Schweikert with the red hair. And here on the right is Story Musgrave, who is the backup science pilot. Basically what they did is, along with thousands of other personnel on the ground, they devised spacewalks and contingencies to help save the space station. I also think, I've also read that Ed Gibson, who would fly on Skylab 4, also helped with designing contingency spacewalks. So obviously we need to give a big shout out to him. All right. So during, to make a really long story short, let me see. So we're gonna talk about the Fix-It crew here. To make a really long story short, during 10 days in 1973, thousands of workers, including the backup crew and the prime crew, they worked together to salvage the space station before it could not be salvaged anymore. A replacement sun shield was devised by NASA engineer Jack Kinsler, and this would later be installed through the space station's scientific airlock. And in addition, the crews actually devised ways using tools from a hardware store. And there's actually a neat movie on YouTube. I'll try to put it in the link. I have a couple movies that I'll link when I'm done yapping. But there's they used tools from AB Chant, which was just a regular hardware store, to help unjam the solar panels. Now, how was the ground able to tell what happened to Skylab? It says here, well, if I told you, I'd have to kill you. I'm joking, obviously, but there were photos taken of Skylab from reconnaissance spacecraft, which verified how much damage happened. So that's really how they discovered it. Okay, so on May 25th, 1973, Skylab 2 lifted off from Kennedy Space Center's Pad 39B off the milk stool. Now, one of the first repairs attempted involved pilot Paul Weitz making a stand-up EVA in an attempt to unjam the SAS-1 solar panel. However, Weitz found it really difficult to get a good lock on the area because of the command module's hatch was in the way. In addition, as he moved, the station would try to make attempts to right itself because he was moving and it was moving as well. So after some time, but not for a lack of effort or expertise, the crew decided to abandon this fix-it attempt. Now we're going to fast forward about 2 weeks. A second EVA, which was performed by Commander Conrad and science pilot Kerwin, did free the stuck solar panel. This EVA was really a game changer, not just for the Skylab program, but just for spaceflight history. A crew had successfully fixed as much as they could an ailing spacecraft in Earth's orbit for the first time. This milestone was very influential on future EVAs, especially during the shuttle program, as ground controllers, workers, and crews devised increasingly more sophisticated fixes for payloads, including but not limited to the Hubble Space Telescope. It also bears mentioning that one of the backup crew members for the first mission was Dr. Story Musgrave, who later would go on to famously service the Hubble Space Telescope. The second mission would see pilot Jack Lousma and science pilot Owen Garriott add to the Skylab fixes by installing the twin pole sunshade in a 6-hour-long spacewalk, which further cemented the space station's heritage as the ultimate fix-it success story. All right. There were 3 crews aboard Skylab from May 1973 to February 1974, and they worked for 28, 59, and 84 days in low Earth orbit, respectively. They would enjoy some of the most of the amenities in space that they had on the ground, such as a wardroom table. They even had a shower. Many of you have probably seen that famous image of Jack Lousma enjoying a shower in Skylab. The ultra-spacious orbital workshop was a place where they could do gymnastic flips and tumbles unimaginable on 1G. But Skylab was not just about astronauts luxuriating and having fun in space. Before I proceed with this part of the talk, I'm gonna hold on. I'm gonna share to another screen, and I'm gonna show you a neat video of Skylab 2 astronauts. Here we go. Flying through Skylab. There we go. Oh, let me stop that, sorry. All right. That was kind of a neat little video of what the interiors look like. It was really awesome. So we're going to talk a little bit about what Skylab actually was up there to do. Skylab was, like I said earlier, was the first scientific platform in space. While the previous Apollo lunar missions, the last 3 missions focused on lunar science. Really, the purpose of the Apollo moon missions was to get footprints on the moon. Skylab was fully dedicated to scientific experiments and materials experiments as well, and student experiments, and we'll talk a little bit about that. So the 3 Skylab crews were among the first people in space to notice changes in bone density, body mass, height, and blood cells in space. They were among the first to realize, hey, we grow about an extra 1.5 to 2 inches up here, and our legs seem to shrink up here. So they were really the first people to notice, okay, your body does undergo changes when you're up in space for longer periods of time. There were also Earth observation experiments. There was sophisticated, at the time, sophisticated imaging that unveiled the environmental trends happening on Earth. And this augmented, at the time, the Landsat program, which had just begun a year before. Landsat is a program that's ongoing now. So it's one of those programs where it really has monitored our environment. And it's not glamorous, but I think in 100 years, we're going to appreciate it a lot. So there were student experiments aboard Skylab, which created interactions between crews and students on Earth. And in addition, there were 2 spiders aboard during the second mission, Anita and Arabella. Some of you may remember this, that inadvertently became celebrities. They spun webs in space. So also, and something that may be fascinating to you, I know this is an astronomy group, and this may be more fascinating, is Skylab also completely rewrote solar physics textbooks, and it strengthened our knowledge of the sun. We'll talk a little bit about that. Skylab had an incredible solar observatory. It had not just 1, but 8 solar experiments. It operated in X-ray, ultraviolet, and hydrogen alpha capabilities. They also had a white light coronagraph, which effectively blanked out the sun, so they could really see an eclipse whenever they could. So and take pictures of what the corona looked like. This is from a book. The bottom paragraph is from a book called A New Sun, and it's talking about how previous to Skylab, they had the orbiting solar observatories, which were 1 meter long, weighed about 55 pounds, and didn't have a lot of power to them. So they were somewhat limited in what they could do. I don't know if any of you remember the orbiting solar observatories. They're fairly old school. They took pictures, but not the kind of pictures that we appreciate now. It was more like they would send data back, and people would plot the data on a point, and it would sort of generate a picture. So not very glamorous or sophisticated. Skylab, by comparison, was bigger than a boxcar and weighed almost 200,000 pounds, and it really had unlimited power, and it could do solar observations in real time. So for its time, this was really sophisticated. I seriously doubt we'll ever see a human-helmed solar observatory like this ever again in our lifetimes. It does bear mentioning that nowadays we have some pretty sophisticated solar observatories in space. For example, I think we have the ESA solar orbiter, and we also have the Parker solar probe, among I think a few other spacecraft as well. And these probably have rendered kind of superseded what Skylab did, but for its time, it does bear mentioning that Skylab took some incredible pictures and really deepened our knowledge of, okay, what is the sun capable of? All right. Before I do talk about this, let me show you another video of Skylab's ATM. Here you go. And this video will show some astronauts working at the Apollo telescope mount interface. Dang it. Let me reshare the screen. I'm sorry. Sorry, guys. Let's go back. Okay. Okay. Now let's talk about more drama. There almost was a near rescue of the second crew. Let me explain that. There were problems with the reaction control system, thruster quads on Skylab 3, which nearly necessitated a rescue mission. This would have brought home 5 astronauts inside the rescue ship's command module, and that the rescue mission would have been flown by 2 of the backup crew astronauts for the second and third mission, and that was Vance Brand, who would later fly on Apollo Soyuz, and Don Lind, who would fly on the space shuttle. To make a long story short, during training, Brand and Lind discovered or stumbled upon that it was possible to re-enter with multiple failed RCS quads. So as a result, the rescue mission was called off and it was never flown. If you go to Kennedy Space Center, Apollo Saturn V Center, the rescue ship is there, so you can go see it. But it was never used. Okay, here's the part that many of you have probably been waiting for. It has often been reported that the third Skylab mission, who were Jerry Carr, Ed Gibson, and Bill Polk, staged a, quote, mutiny aboard Skylab in which they went on strike. They stopped talking to the ground, and it was just a lot of drama going on. So what really happened during Skylab 4's early days? Well, we're going to talk about it a little bit. So, guess what? Surprise, there was no mutiny. We'll go through this. This is really an entire talk into itself. And I've actually done a talk about this entire issue here. So I'll try to keep it short, because if I had a chance, I'd be here for about 8 hours discussing this. But the third crew was overscheduled from the onset of the mission. What happened was they were the last Skylab mission. There was none planned to go up. Everything was canceled. NASA was putting most of its energies into funding the space shuttle by that point. So this was it until the space shuttle for science mission. So they had a ton of experiments to do. Basically, everything was just layered on top of another thing. So they had a lot to do. During a few orbits, the crew were switching off communications. Like one would monitor at one point, and then they would switch it to the other crew member. They would do shifts, which they found worked effectively. At one point, they accidentally turned off all communications, which has contributed, which obviously I'll say again was an accident, but this contributed to the myth that, they sort of went, they were raging against the machine and they stopped talking to the ground. The crew did not go on strike. They did have a day off, but it was authorized by the ground, and the crew actually worked on this day off. Gibson, for example, was actually doing experiments at the telescope mount, observing the sun. So it wasn't like they were, just chilling, whatever, not doing anything. So the day off did not fix the long-term problem of the fact that they had just activities scheduled one on top of the other. So at one point, the crew in the ground over several orbits, because remember back then they didn't have the TDRS system; they had to use ground stations. So basically, when they were in proximity of a ground station, they and mission control tried to work out a better schedule. This is underscored by the mission transcripts. If you actually go back and read the transcripts, it's there. So why is there this myth that still persists to this day? There was a flawed Harvard Business School study. There was a extremely terrible book in the 1970s called The House in Space that also perpetrated it. And there's also been a lot of articles and blog posts which have gotten it wrong. So I do want to say Skylab 4 is my favorite mission. they did a heck of a lot of work. They were very successful, and they went on to even observe comet Kohutek. For you all who are, I know this is an astronomy group. They actually, probably the most famous astronomy experiment was them seeing Kohutek, and they actually used an instrument that was used, not the same instrument, but it was a similar instrument that was used on Apollo 16. There was a electrographic ultraviolet camera that they used to get some images of that. So yeah, let's talk a little bit about Skylab's hardware heritage. Now, the Skylab Apollo telescope mount digital computer system was the first redundant digital control system on a spacecraft, on a crewed spacecraft. Redundant means there were two computers. What would happen if one computer failed? They could switch over to another system, so they wouldn't, be spinning out of control or not oriented properly. So they had a backup. So this was very effective. They never had any failures. I think they had to. They did a scheduled switch from one computer to the other, and it worked perfectly. So this was very robust, and this was heavily influential on the space shuttle program, because the early space shuttle program utilized 5 GPCs, general purpose computers, and they were the same type of computer as the ones used on Skylab. They were variants of the Skylab 4 Pi computers, which were by IBM. If you look at this picture, this is Dr. Ed Gibson at the Apollo telescope mount. If you look at this bundle, I'm pointing at a bundle of wires here. The interface for the control system, the computer, is right here. There were several, I think there were 7 numerical keys on it. Looks very different from the kind of computer you'd see nowadays, for sure. All right, we're getting near the end of Skylab. So there was a plan to reboost Skylab. As I said earlier, in 1974, the Skylab 4 crew did boost Skylab's orbit before they left. But by 1978, it was becoming really apparent to ground controllers that its orbit was starting to decay because of increased solar activity. So there was a plan to launch the space shuttle and attach something called the teleoperator retrieval system, which was kind of like a inertial upper stage to it. And what would have happened was this mission would have been helmed. They actually had a crew for this mission. Fred Hayes would have commanded it, and Jack Lousma, who actually flew on Skylab 3, would have piloted it. And Lousma was to remotely connect the stage to Skylab so that they could reboost the orbit. A few things prevented this mission from happening. Number one, Skylab was really coming down too quickly. The sun was really doing its thing on it. It was coming down too fast. And the other thing was the space shuttle was not ready yet. It would not fly, as we know, until April 1981. So it just was not going to happen, unfortunately. The mission was supposed to be called STS-2A. It was to be the second space shuttle flight. Instead, the real STS-2 flew in 1981, and it was piloted by flown by Joe Engle and Richard Truly. So this would have been really cool had it happened. I wish we could have seen it. So, all right. Now we're at the end of the talk. A lot of people ask, Emily, why are you so obsessed with Skylab? It's an ancient space station, it's so old school. Why are you into this? And I have to say I'm into it because if you look in the sky, if you get those ISS passover, flyover alerts, if you look at the ISS, that's its direct descendant. A lot of the Skylab astronauts actually worked on the ISS. I know Jerry Carr did extensively. Yeah, if we didn't have the medical data from the medical data and some of the other operational data from Skylab, we really wouldn't have had, a good foundation to go into the ISS. so yeah, its legacy is momentous, and it really showed us how to live in space for very long periods of time, well, comparatively long periods of time. It showed Apollo, the lunar program, up to that point, not to diss the lunar missions at all. The lunar missions were incredible, but they were really just kind of camping trips. They'd go up to the moon for a few days, live there for a few days, and come back, and which is fine, but it didn't really teach NASA how to actually live and work in space for long periods of time, whereas Skylab did. That's very important, not just for living on the ISS, but it's also very important for if we establish a foothold on the moon where people are going to be staying there for a while, or perhaps deep space at one point. If we send people to Mars or perhaps another destination where they're going to be up there for probably more than a year. So that's Skylab's legacy. And if you go outside to the ISS, you're looking at its direct descendant. This morning, going outside, seeing that SpaceX launch that I talked about earlier, that's its legacy. So that's why I love Skylab so much. So I think that's it. All right, I know this is a lot of small text. Here's some sources and some recommended reading. Probably the best narrative book about Skylab is Homesteading Space, The Skylab Story, which was written by David Hitt, Joe Kerwin, and Owen Garriott. The latter two actually flew on Skylab. That's a really great book to get if you're just starting to learn about Skylab and you want to know more, and it's a really good narrative about the whole thing. Dwight, who was introduced earlier during the talk, has also written NASA, or compiled the NASA mission reports that have data from all the missions. So those are really a good addition to your library if you'd like to know more. And also the film Searching for Skylab, which Dwight also directed, and I am a technical consultant in it. So those are really good places to start. I know David Shaler. Some of you may be familiar with him. He's a pretty famous British space historian. He also did a pretty fine Skylab book as well. So yeah, so that's basically it. Well, that's not it. I could go on about Skylab probably for 8 hours, but that's the end of my talk. All right.
Thank you so much, Emily. That's wow. That's a great overview of a very complex and extensive program, and I think a lot of people learned tonight some background pieces that that they may not have been familiar with. Yeah, I've asked Dwight to post a link in the chat because he's on a rather bizarre time zone from us now. So I think he's in the middle of the night, so he's going to be leaving us in a minute. But I asked him to post some links to at least to his film.
Okay.
So now is a great time for some questions for Emily, and if you want to post them in the chat, that's probably the best way to do it. While we're waiting for a few questions, I wanted to acknowledge one person who's joined us, someone who I met at a Space Fest who has a bit of Skylab history, and that's Herb Baker. Herb, do you want to come on board and tell us a little bit how Skylab impacted your family?
Yeah, hi. Yeah, well, I actually have hi, Emily.
Hey there.
I have a couple of connections. I grew up near the Manned Spacecraft Center, which is now the Johnson Space Center. And so actually I guess I was going to say I was a teenager. I was actually about 20 in 1973. I covered working for the news media. This is before I started my professional career at NASA. I worked for the news media covering a couple of the Skylab missions. And then my other connection is that my mother was involved in creating the parasol. She sitting at the sewing machine, the official NASA photo, her sitting at the sewing machine with three people helping her guide this 22-foot by 24 feet piece of material through the sewing machine. And so I got to be in the movie too, which I really enjoyed to tell her story because she passed away several years ago. So yeah, and I always enjoy hearing Emily talk about Skylab. I think I love it just about as much as she does. So you really enjoyed it tonight. Thanks.
Thank you.
Thanks for coming on, Herb. Good to see you again. Emily, first question is: did they ever determine the problem with the cause of the RCS failures on the Skylab 3?
That's a great question. Honestly, I'm not even sure what caused it. There is a funny story from Jack Lausma where they were about to dock with Skylab, and he sees what looks like a thruster floating by. So he says to Alan Bean, "Hey, I think one of our thrusters flew by." And Alan Bean was like, "What?" And turns out it was a piece of ice that had formed in one of the failed thrusters, and when they were docking with the space station, they were kind of off. So they had to kind of work a little harder to right it since they had a damaged thruster. So honestly, I maybe somebody else knows, and that's fine. But honestly, I'm not sure what caused that to happen. It could be something as innocuous as maybe, a little piece of, something when they put it together, may have gotten in it. Who knows?
Yeah, because of course, the Apollo spacecraft had only, flown for up to about 10 to 12 days at a time. And now they're being asked to fly for 2 to 3 months. So anyway, the outcome was good. Question about the demise of Skylab and just a little bit about the solar activity and how that how that caused the decay of Skylab's orbit.
Okay.
I'm sure you have some background on that.
Basically what happened with that was, some of you may have heard of the satellite Solar Max. It was launched, I think, in 1980, and because around 1980, it was supposed to be a really hot year for solar activity, so they wanted to get something up to see it. And that's really a whole other story in itself, because Solar Max had to sort of be rescued at one point. So what happened was, by 1978, people at NASA had been really sort of conservative in their estimations about how the sun would be activated going into the solar maximum year, which was 1980. So they were thinking, Skylab, okay, it should stay up by 1983, but then it became very apparent by early 1978. Skylab was starting to appear on decay list, because basically what happens when the sun gets more activated, I guess that's the way to put it, the atmosphere swells. So it began, and Skylab operated mainly in a pretty high drag state. It operated mainly in solar inertial because its job was to observe the sun. I don't think it was, so basically, it was already in a state where it was, kind of being sucked down by the sun more, or the atmosphere, if that makes any sense. So, so by 1978, NASA was trying to reactivate it, and they did reactivate the computer system, and they invented a couple of extra modes to control it. One was called end-on velocity vector, and the other was called TEA, which was for reentry. TEA is torque equilibrium altitude. And these were, an end-on velocity vector was basically a low drag profile to minimize it coming down further. Unfortunately, that didn't work. So by mid-1979, they knew it was coming down. There was really no way they could try to bring it back up or anything like that. So yeah, so I think at one point they just switched it back to solar inertial, and at the end they put it in when it got to, I think, around 80 miles in altitude, they put it in TEA, and that was basically to try to control its reentry. and they got most of it over the Indian Ocean and some of it over Western Australia. So let me find that awesome video. Let me find that awesome video from the ABC Australia, and I'll put it in the chat.
Oh yeah,
And
that'd be great. It's an amazing view of. Well, it's actually the reentry is actually reminiscent of other reentries we've seen, like of Columbia or external tanks. One comment from that day I remember is that there was some. They were really trying to put it in this long orbit over the Atlantic Ocean, where it started out over New York State and ended up going all along the southern tip of Africa and then up to Australia. So it was a really long stretch of ocean. And they were concerned that they might be a little short. And that would have put it over the Maritimes and southern Ontario. So I think what they did is they adjusted the attitude to make it go a little long, but of course it's an inexact science. And they went a little bit too long and ended up in Australia. But they did a masterful job of putting it more or less where they wanted it to go.
Yeah, and I kind of resent I kind of resent, there were a lot of jokes about it going over Australia, parts of Australia. That was not really the intention. NASA was not trying to. If you watch the video that I put in the link from YouTube from ABC Australia, there are actually people in Australia who had conspiracy theories that it was on purpose. It was not. It was not on purpose. It was just by happenstance that they were trying to put it in the Indian Ocean, away from people. But unfortunately, the reason some people ask me, well, why did it come over parts of Australia? That's a great question. The reason why is because it was really robust. It was a space station. It was very well constructed. Despite its launch injuries, it was actually pretty robust, and it held together for a very long time. It held together longer than anybody expected. What probably happened was the solar arrays probably went first, and the rest of it kind of broke apart. And then parts of it just held together over Australia, and the rest of it just broke up over there. So, yeah, it was very, the 1970s, people laugh about the 70s, and make fun of the clothes and fashions from the 70s. NASA and JPL built some amazing spacecraft during that time. Yeah, like I said, Skylab was actually pretty robust, and I mean, look at Voyager. So they're still going. I mean, yeah.
And it's interesting. I know, Emily, you might want to comment on your trip to Huntsville, but they built 2 Skylabs, and one of them is at the Air and Space Museum in Washington. Mm-hmm. So you can see an actual Skylab. And maybe tell us about what you saw in Huntsville.
Yeah, last year I actually took a trip to the U.S. Space and Rocket Center in Huntsville, and they do have one of the Skylab trainers there, and they have another Skylab outside, which I believe is the underwater trainer that they used, and it has a little astronaut on it. I call him Ed, after Ed Gibson. But I don't have the pictures on my computer, unfortunately. They're on my Facebook, but I did actually get to see the Skylab trainer in there, and that was really amazing. The thing that's most remarkable, if you get to see the Skylab, there's really 3 decent Skylab mock-ups. There's the one in Huntsville, there's one at Johnson Space Center, I think at Space Center Houston, and there's the one in the Air and Space Museum. And that's the one at the Air and Space Museum is actually the second Skylab, Skylab B. That's really another story in itself. At one point they were supposed to fly it, and it got canceled. And there were some really interesting plans for it. They were supposed to do they were thinking about doing an Apollo Soyuz utilizing the Skylab B at one point. And there were also kind of plans for it to be used during the space shuttle program for what would be called the Advanced Skylab program. And before it got canceled, there were astronauts making plans to do experiments on there. I talked to Dr. Phil Chapman last year, who was a former NASA astronaut. He also bears the distinction of being the first Australian-born NASA astronaut, and he was actually devising experiments with MIT for Skylab B, but unfortunately it got canceled. But I kind of got a little off base there, but there are actually some pretty decent Skylab mock-ups. But the one in Huntsville, the thing that struck me about going in it was, I looked around, and of course there's, the bicycle experiment. There's, there's the shower, there's the gridded floors that are have the sort of the triangular shape and stuff. But when I looked up, I was like, oh my God, because when you looked up, you were looking into the orbital workshop, and it is gigantic. I mean, it's a really big volume of space. Like, I was really mentally not prepared to see that, because it's sort of, it's hard to explain. It sort of brought me into a mind of like a way of thinking about, like, okay, this is how you have to think in space flight. You don't think of things as like sort of a room. You think of things like on Earth, you think, okay, I have a room with like 4 walls, right? In space, you think of everything as sort of one volume. So that was probably the thing I got the most from that, was that what a large volume it was. And I was like, wow, if you were actually floating in here, you could, sort of use that whole volume to do whatever you had to do. It was really cool.
Yeah, some of the best video is the one of the Skylab 500, where the astronauts are actually running around the circumference of the workshop. Oh my God, they had so much room in that thing.
Yeah, they had a lot of fun in there. It was awesome.
We're really getting historical here, so I will comment on the movie Maroon, which is of course a movie that came out just before the first moon landing. But it was about 3 astronauts who went to a Skylab, which was a wet orbital space station. So that's, if you ever watch Marooned stars don't come to me right now, but James Franciscus and whoever, but and Gregory Peck, of course.
I think Gene Hackman was in it.
Hackman, yeah, just David Jansen. Great movie, and a lot of neat space stuff. And in fact, during some of the scenes, you can see some of the Kennedy Space Center PAO people running around in the simulated hurricane, lugging cables here and there. So anyway, all right, let's take a few more questions. Let me take a quick look. There was a comment about the high altitude. I think Chris Gaynor mentioned earlier, as we were starting up, that Skylab was actually the first manned spacecraft to pass over Canada because of the high inclination orbit. All of the Mercury, Gemini, and Apollo spacecraft had low inclination. Although I guess maybe here's a question: did Titoff's mission maybe pass over Canada at one point? That's a great question.
I'm not sure about Titov's mission. Hold on. The reason why Skylab it had we talked a little bit about this, I think, before everybody came in. It had a 50-degree inclination, and I think it originally was supposed to have a 28-degree inclination, but there were scientists who did not like that, because at 50 degrees you can see most of the Earth. So, and Skylab, one of its main objectives was it was supposed to take a lot of photos. It was supposed to do Earth observations. It was supposed to take a lot of pretty high-resolution photos of the Earth, and a lot of these photos are still available nowadays if you want to access them. They're quite beautiful. So let me say goodnight to Dwight.
Dwight's on his way. Good night, Dwight.
Night,
Sorry,
Dwight.
I didn't mean to butt in, but thanks everyone for showing up. Thanks, Emily, for the great show. Thanks, Randy. I'm sorry, it is nearly 3 o'clock in the morning here, and I have to work tomorrow, so I'll put another link in to the website. Thanks for showing up, Herb. Great to see you here. Thank you, everybody, and I'll let Emily talk again. Sorry about that.
No problem. Thanks. Yeah, I guess any one day early Soviet mission would have passed over Canada, given the 52-degree inclination of Baikonur. So it's interesting. All right, we're going to take a few more minutes here for questions. But I think it's been a great evening of reminiscing and a little bit of history here and there of early space station, the early stage space station program. So I'd like to thank Emily, our guest, very much for taking the time to share her knowledge and experience with us. And thank you for our guests who don't normally join us for our ESC meetings. It's great to have you with us. Let me just tell you a little bit about our next couple of meetings. May 14th, we have our next members night, which will just be generally a short presentation night, our potpourri night. Mars has been in the news lately, and many of you know that the Royal Ontario Museum in Toronto has a very large meteorite collection and Mars meteorite collection, and Kimberly Tate is the curator of that, and she's also been selected to work on the Mars mission sample return mission that the current mission is really the first of three to see Martian samples coming back to Earth in about 10 years from now. So Kim Tate is actually working on where these samples would be housed, how they would be handled and studied. So if you're familiar with the Lunar Receiving Lab in Houston, which is where all the Apollo lunar samples are stored, they're going to have to create something to handle the Martian samples with the Mars Return mission, which again is scheduled to return Martian samples to Earth in 31. So she will be our guest on May 28th. And with that, I'd like to thank everyone for just a great presentation, and thank you for all your participation, everybody. In the chat, there's a lot of comments. Emily, thanking you for just a great presentation.
Thank you all so much. This was so much fun, and I'm really honored that I always wanted to do a talk for the RASC, and now I did it, and I'm very happy. Thank you. I'm very honored to be here.
Well, we'll look forward to having you up here in person sometime once things get back to normal.
I would love to. Thank you.
Great. So thanks, everybody. Take care and stay safe, and get your vaccination as soon as you possibly can. Good night. Take care.
Good night.
Emily, why don't you stay around for just a couple seconds?
See you next meeting, everyone.
Okay,
Nice to meet
guys,
you.
Take care.
Let me see.
That was excellent. Thank you very much. Wow.
No problem. That was a lot of fun.
Yeah, it really was good. It was great having Herb on and Dwight, and that was
Yeah, it was a lot of fun.
Really interesting topic.
Thanks.
It is, and there's so much. I left out so much. I know y'all are an astronomy group. There's actually a few. If you can find these are from the 70s. This is it's probably back. I don't know if it's backwards, but this is a Skylab astronomy, because they did do some astronomy imaging other than Comet Kohoutek. And if you like solar astronomy, the book A New Sun is a pretty cool read. Some of this stuff is obviously it's pretty outdated because of the year, but it's still pretty fun to have. So
they published so much great stuff back then. I guess once so many things went online that they just stopped.
What's that?
Leaving our place.
Okay.
Okay, Emily. Well, I won't keep you. I'll send you an email. We'll arrange for to
okay.
to get to you. But stay safe, and thanks again. This is just awesome.
Thank you, and have a great night.
Okay. Good night, everybody.
All right. Good night.